What's his name?
Actually, that's John. Yeah. Sometimes you can say that. I guess when you go back to call.
I'm waiting for Etherpad because last time when I found this, I was correcting some of the Etherpads. Should we go ahead and get started? Okay. All right. Good afternoon, everyone. Can you hear me? Yep. Okay. So this is the Teep working group. So just to let you know, in case you're not here for Teep, that's what we will be discussing. So orders of business, I'm not going to read the whole note well. Hopefully you know all this by now. The blue sheets should be going around by now. I know on my left-hand side, they should be halfway through, if not already. But just make sure you sign the blue sheets. So in advance, I will thank Roman for being an Etherpad and Mike for being one of the note takers. I would like to have one other note taker and a jabber scribe. We actually need a jabber scribe. So could we get a volunteer or two, please? Jabber scribe? Anyone? Thanks. I don't know your name, sorry. Oh, I need to put my glasses on. Hi, Mike. Thanks. You think one note taker is enough? Could we get a second note taker? Thanks, Mike. Yeah.
There's a typo on this slide. Those should say IETF 102. If you're looking to join things and type stuff on Etherpad, make sure you join the IETF 102 ones.
Yeah, that's my bad. You can see my cut and paste doesn't always work. But yes, this is the IETF 102. So please make sure we note that down. Okay, so let's bash the agenda. So for today, the authors have updated. So at the last face-to-face meeting, we agreed that we needed to have a working group architecture draft. So thanks to the authors, there's a draft that's been posted for a week now. So Hannes and Ming will provide the overview for that. There's already been some comments, which there'll be discussions. There's also been an update to the OTRP solution draft. Again, comments, but there'll be a presentation for that. We actually had one person, and that's my co-chair, who will be presenting his report thereafter. And then given some of the comments and feedback, we think it would be a good idea, and Dave volunteered to provide not really an SGX overview, but rather in the context of Teep, how SGX would fit and some of the things that we'll need to work through. So that really takes us to the end. We have a full agenda. So I will, while I put 30 minutes in there, depending how the Q&A goes and the presenters, I may reserve the last 5 minutes for Q&A. So it may be that you only get 25 minutes. And then we'll go from there. So that's what we have on the agenda today. Any objections, any other comments? Going once, going twice? Cool. Okay, so let's go ahead and get started with the review of the milestones. So at the last face-to-face, we had put the tentative, we'd already moved some of the dates forward because we said we would have an architecture draft, which we didn't quite have it in March. So we've gone ahead and just adopted a draft, which, how many people have actually read the draft? I'll probably ask again. Just a few. Yeah, but it's mainly the authors and a couple of commenters. So we're going to need more reviewers. Yeah. For those on the remote, there were about 8 hands, but realistically, half of them are the authors. So anyway, we've gone ahead and adjusted the milestones to ensure that we can stay on target, which is why we put in place, can we and are we on target right now, given the dates? So Ben has actually.
Yeah, the parts in red have been updated since last IETF. It was discussed at last IETF that the milestones were kind of wonky, that they had one case where like we submitted to the IESG before adopting it as a working group last call and things like that. And so those dates we believe are consistent with the discussion last time, and the data tracker now shows the parts in red, but that's not something we've shown you before other than what we were going to do. Now we're just reporting out that these are the dates that are listed right now.
Okay, so if there are no comments or issues, I think we should move on, given that we have a full agenda. Let's move on to the Hannes. Yeah, well, Ming and Hannes, but Hannes.
I was just wondering whether like it would be more sensible to use the March IETF meeting for getting the architecture document done, or have that in February so it's finished in March, for example.
So the rule of thumb we were following when coming up with the months is to start a working group last call that would conclude at an IETF meeting, discuss any last call comments at the IETF meeting, and then submit it afterwards. And so that may be in one IETF meeting, you had first working group last call, the next one you have other discussion, but the point is we decided to submit it right after the IETF meeting instead of right before, so that we could make sure that we had consensus on it at the meeting. That was the goal, why it's exactly 1 month after an IETF meeting.
So it's not completely random. Okay.
Correct. So the April one is right after the spring IETF, and the December one is right after the
November. Right. Okay, so if there are no more comments, who wants to start, Ming or Hannes, on the architecture? Okay. Oh, that's a good point.
Right now, it's still this one, but if we can find the second one, that's the one on here. Well, looks like it's long enough, but we can find it. Oh, did you find it? Excellent, thank you.
Hello.
Great. Yeah, just talk into the empty stand. Yeah.
Okay. Hello. Yeah. I'm Ming Liang Pai. I'll talk about a quick introduction of the document status. So we submitted the document, first draft, work group draft, about 2 weeks ago, as in July 2nd. We already received a couple of good comments in the mailing list about the draft. The content itself is largely from earlier Open Transit Protocol draft, right? That was a combined one, which has architecture and protocol. And after that document is adopted, right? After the document work group adoption, then we split into half. But this has more on that, right? We started to address some comments from last work group and also additional feature request for that. So we try to address those feedbacks there. So the current document structure is here's a content quick one, right? We have a brief overview, then have terminologies. That's one area I think Hannes and Dave will talk more. We have terminology itself because so many definitions. There's used in different industry or used in different forums. We really need to define what the scope of this architecture should cover, because there was initially, TE itself has from trust zone and has different background versus SGX and so on. So that what the scope would architecture address. And we'll talk about the use cases where this Teep applications or technology can be used. Really, the 4 primary areas we talked. So please, we welcome you to read and give us more feedback, other use cases, right? So today it has been used in payment, right? You have a secure application to do payment transaction, used for authentication, right? Device used as authenticator. and a large use of IoT devices. Now you have embedded security there. And the one more added is cloud computing. That was really added from David and others from 2 working groups before. And so now cloud host provider does not want to have a liability knowing a tenant's data, right? So host my application in the cloud application, cloud host provider with Azure, AWS, or Google, right? I can run my application there, but they do not have to know what I'm running there. That's a very valuable use case. So that's the addition from original OTRP. Right? Then we start list of the really architecture. That's a core piece, right? Core piece to address the use cases. Amongst architecture, there's one special piece called agent, which is facility communication between the TAM and the. I don't go to detail here because this is a third one already. So just good, and talk about the attestation logic and the standard security consideration. So there are some few changes I just quickly highlight here from the original OTRP draft. Right? So one is get comments from multiple people. Right? Terminology, right? Terminology unification. So there was a concept of secure boot module and trusted firmware. So now we only have pick one, right? Trusted firmware is the one we choose to use, right? So that's for secure boot. Now they have the concept of security service provider, application developer, TA provider, and so on. So then what that terminology we should use. And this particular service provider, there will be more discussion later, a slide for that. We added a diagram about what the user experience look like when using trusted execution environment, when to distribute, deploy, running, and manage a trusted application. So there's an added diagram for that one. And based on the feedback, which is one feedback, trusted firmware verification become optional now. It's not required. Like in SGS case, it's not needed, so we make it optional, the proposal for that. We also added one to make transport support as a requirement. It was optional in the very beginning, right? Now we say this as architecture guidance that any solution document should provide the transport support. We also try to make assumption that architecture support multiple TEs. How to address that one? That will leave it to solution implementation wise, right? But the architecture that is. And make the binary distribution 2 ways. One's by TAM, one's by cloud application. How to that done? But as architecture, that's more to come up. But that's assumption that's one we want to address. So that's a main scope of change introduced there. So that's one. So that's all those open ones that now try to harness. You go to depth that.
Thank you, Ming. So the first item, as Ming already mentioned, so we had this, from a historical point of view, this notion of trusted firmware, not trusted in comparison to untrusted firmware, but the notion that there would be firmware, specific firmware running during the boot process that has sort of a secured boot process for keeping the trust zone technology in mind. And so we had an agreement earlier based on discussions with David and others on a mailing list that we would get rid of this because this turns out to be a difference between the trust zone approach of implementing a DE versus a SGX-based approach. And David is going to talk about this more in his presentation when he goes in explaining some of the SGX background. So we tried to do that, or we tried to massage the document to get rid of these different text segments that are relevant to this trusted firmware, but there's still sort of reading through the document after the submission deadline, I realized that there's still some leftover, so there's some editorial work that needs to be done, which will be done in the next version, but I think we are settled on this, and the motivation for it will come later. We could do probably a better job in explaining some of those architectural differences between the different, at least between those types of DEs. I think that could be quite informative for everyone, not just for the audience here, but for others who are not involved in the process. I think that's quite, if you are into the hardware design and the security design of hardware, I think that's a pretty cool concept and difference. So we'll keep that short. This one is an important one that we should spend some time on. And it's also something that Dave has created a few slides with message charts or message diagrams to talk about the app distribution or the anticipated app distribution. So one that we focused on first was the second one, the second mode, which is sort of the trusted app being distributed by the DAM. And that was all along in an initial version of OTRP. But then later, there was also this notion added of having the binary, DA binary bundled with the client application, which would be more the notion of SGX and could actually be used also with independently of the underlying DE. But it was just not a model that we looked into specifically. There are some side effects of doing that, and it will be covered in Dave's presentation. So this is definitely something we need to make a decision on. One aspect as a food for thought on what the challenges or the implications are is that when you think about not just passing binaries around that are the same for all of the devices, but binaries that are actually personalized or that have binary instance specific information. So like if you think about the web and the application distribution, there's a lot of customization for the individual binaries sometimes done that are being downloaded. Easier obviously with JavaScript and for these type of things. So this is something that the DAM has taken over responsibility. It's probably not as explicit as it could be in the document, but probably worthwhile to point out. This is since this is actually functionality being used today. There's also the question of like how over the life cycle is the application updated, the client application as well as the then correspondingly the trusted application. And I just wrote a few questions there, like who authorizes that update of an application and the DA, and also what would be the security domain. And we're going to talk about the security domain in a later slide in case you forgot the concept. So this will also be covered in more detail in Dave's presentation. There's a topic that came up on the mailing list, namely the question about a device having one DE or multiple DEs. That can come in a single processor having multiple DEs or having even, for example, different DE technology, like having a trust zone component in the processor and a separate DPM chip, for example. In the use cases we initially worked on, we focused on the one DE per device model, which is sort of like the mobile phone type of use case. And then this other model or other deployment situation came along. And that there, the primary question that was raised through this sort of expansion in the architecture was how do we actually make sure that the messages that come from the DAM, how are they actually routed to the right DE, since there are now multiple of those. And an assumption that, and we're going to talk about the Teep agent terminology as well. So there was this middleman that relayed the OTRP messages back and forth, and it didn't have any understanding of the content of those messages. It was purely a relay, passing messages from the secure world, if you will, to the DAM and backwards. So how can we do that? And Dave was kind enough to put a slide together to actually, in some sense, answer that question, or at least have a proposed answer. Do you want to jump over here and talk about that?
So the one use case that came up at, I think it was at the IETF 101 meeting, it could have been on the mailing list, but the one example that somebody else gave, and I can't remember who it was, maybe it was somebody in this room, said, well, I had that the reason that I have multiple TEEs is because they're of different types, right? Maybe I have, you know, a TPM-like thing and a non-TPM-like thing. They're of different categories, right? And so if you have a TA binary, I can't just pick any one of them. It's a TA binary that's written to go in a particular type of TEE, right? This is meant to go inside SGX, or it's meant to go in trust zone and not the other thing. There's multiple things. And so the example case that I'm showing here is for a case we have heterogeneous TEs on a device. And so a binary is written to go for a particular type. And so the distinction is type A and type B, whatever those are, okay? And so this is all supposed to be protocol agnostic in terms of the picture here. This is architectural, right? And so at some point, some application or installer of an application, this is step one, gets the notion of, I have this TA I need to be able to install that such and such depends on it. And here's some constraints about it. Like this is a binary that's meant to run on a blah processor inside of a particular type of thing, right? This is a signed SGX DLL, or it's a .A trust zone binary for such and such a processor, and so on. So at this point, the box that I'm labeling facilitator, and we'll talk about the terminology later, in this example, protocol independent, he knows because the metadata says this requires a type A TEE, and he knows he's running on a box with type A and type B, so he knows which is the correct OTRP client that needs to be the one that's communicating with that TAM for purposes of finding out whether it can install TA X. Okay, so in this case, he knows that it goes to OTRP client 1 because he's the one that's in type A. That's the routing decision in this example slides. It's done at the time when the first API call is made into the TE. The outside knows which one it is based on the metadata. That's the proposed answer to the open issue. Okay. At this point, now you can set up a session that's an OTRP session between that particular OTRP client and the right TAM, and this is not a slide about picking the right TAM, that's a different question, right? But assume you can pick the right TAM. So there's a transport session that he facilitates. And so if you had two different clients for two different TEEs, or two different trusted applications, you have two different transport sessions. So you can see the transport session is tied to going between a particular TAM and a particular TEE's OTRP client. And so any messages that come from the TAM come in the context of a particular transport session and are obvious which one to go to. It's the one for that session is bound to this OTRP client. Okay. So that's my answer. The routing decision, if you will, is made at the time that the metadata is used and the facilitator starts to open up a connection on behalf of a particular OTRP client. And after that, the answer is easy. So this is my proposed answer to the open issue. Using, again, the use case that was discussed last time by somebody else that says I have heterogeneous TEEs on the same device.
Good. And the good thing is that it doesn't require any new standardization work.
This requires no changes to OTRP protocol spec.
Yeah. Okay. Actually, this is also a placeholder slide to point into what Dave is going to talk about with his experience working on the implementation. It addresses the question of like, how does the message interaction actually work between the client application, the TAM, and the DAs? And Dave tried out a couple of different approaches. He posted that question to the list beforehand, before he then went off and experimented with the code and to see what how he can actually answer it to yourself. So that's why I leave it to Dave to actually answer his own question. So that's a quite a pragmatic approach, and that's yeah.
Yeah, we had a lunch discussion, and so this was actually my diagram that he included into his deck. So one of the pieces of feedback on the architecture document was the term agent, as used, is an English word that doesn't mean to most people what it means in the document, right? In normal English, an agent is somebody that is authorized to act on your behalf. In the document, the term agent is used to refer to something in the rich operating system in the rich OS that is not authorized to act on your behalf. Okay. And so the point here is agent is probably the wrong word to use for the thing that's not authorized to act on your behalf. It's just authorized to relay messages it can't understand. Okay. And so this is a purely editorial terminology question. It's to say, can we pick a word other than agent? And so you'll see for slide discussions, I threw in the term facilitator. I don't care what it is, right? Facilitator, connector, or something else. We just need something.
Well, for those of us who remember Grapevine, how about broker?
Question to the room. I see 2 thumbs up and a bunch of blank stares. I see. Okay.
Okay, we're kind of all over the
Right.
map. I don't know.
This may be a discussion for the list, right? But the
Right.
point is, the thing that we're talking about is this piece out here. We need a name for it. There's an OTRP session that's encrypted that goes between, or at least authenticated, if not encrypted, right? That goes between some server thing over here and the term that's over here. The document doesn't actually have a term for this piece, right? Here, I made up a term, OTRP client. It has a term for this right here, which is called agent, that I didn't like. And whether you call it a broker or whatever else, we can take that to the list to see if other people come up with better names, right? I don't care what it is, but the point is, we need to have a common name for this piece and a common name for this piece.
This means, I think this is a good point. So original was agents try to say it's on behalf of the rich app talk with TE. So that's kind of on behalf. But I think now take the either right as a transport connector something. It's a more neutralized or good.
We'll post it to the list and add some new term for it. Another terminology piece is the service provider, and currently it's defined as an entity that wishes to supply trusted applications to remote devices. But then the document, the architecture document, goes on and it provides a little bit of extra text and also distinguishes between a device administrator, and it says a device administrator or service provider of the device need to determine security relevant information of a device before provisioning the DA to the device with a DE. And a DE in a device needs to determine whether a device administrator or a service provider that wants to manage an DA in a device is authorized to manage applications in a DE. So Dave came along in his review and asked on whether the device administrator is actually responsible for controlling what apps run in the DE on, for example, an IoT class device, and whether the device administrator is just another form of service provider, or whether those terms are actually mutually exclusive. And it's a little hard. It's obviously not a straightforward answer. That's why it's still an open issue. Currently, so I'm a little bit mixed about this one, to be honest. So we had initially the notion of service provider and application developer or developer. So we got axed the developer term and replaced it. I had only the service provider anymore, but now the role of the device administrator is a little bit unclear.
I would like to clarify a little bit. In the original document, it was only service provider. So service provider like a bank, right? Bank dedicate the trust application installation to devices through a TAM provider. So service provider like a bank kind of a concept. And then there's a device administrator as a use case was asked, right, in a last work group, in a 101. So now to come back, device administrator may means a manufacturer, maybe a person who manages the devices. It's different from bank. So it's for me, it's a different terms. So there's a 2 use cases here. It's not the same. So for that.
So Dave Thaler. So I asked, what's that? Yeah, I think it's on. So Dave Thaler. So I asked the question as an individual reviewer of the document, and I like the first definition, meaning the top bullet on the slide. Right? I think that one is unambiguous, although I I would tend to prefer a term like TA provider rather than service provider. I think it's actually much closer to the definition and more clear. But that said, the question came up out of the two sub-bullets that's there where it has the or that's in there, okay? My preferred resolution of this terminology is to say, if blah, 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 is the device administrator just another type of provider? Answer, yes, would be my preferred resolution. And if it's defined that way, then you don't need those ors in there. You'd say a TA provider needs to determine, and a TA and a TE and a device needs to determine whether the TA provider wants that, so on. And so on. You wouldn't need to express them both because the device administrator is just a subcase of one particular type of TA provider, right? And so that's my preferred resolution. I'm happy with other approaches too, but we got to be talking about the same thing. We're just talking across each other.
Dave Wheeler from Intel. I see a device administrator as fundamentally different, as making a decision of what can be on the device. So that maybe that device administrator is managing the set of trust anchors, right? Or is authorizing the TAM to make the decisions on behalf of them. So it may be some sort of ecosystem around enabling a TAM on a device, either through the trust anchors or directly through enabling what TAM has access. But I think that needs to be built into the TAM kind of interactions, and the TAM is sort of the entity that takes the place of the device administrator because he's making a lot of decisions on what TAs get installed and signed and things like that. And then the service provider is just the one who is asking for a particular TA to be installed. That's the way I see it.
I don't disagree with anything that David Wheeler said. So I don't have to.
Stu Card here. I think this comes down to scope of authority of the different roles. And my instinct is that a service provider defines the rules of engagement that a particular trusted application would go by if I choose to install it. And that's up to that service provider, and I get to decide whether or not I'm willing to adhere to those rules of engagement. Whereas a device administrator is going to determine whether or not I'm actually even going to enter into that relationship with the service provider in the first place. And so it kind of comes down to the interpretation of the subtle words, wishes to supply TAs.
Can you stay at the mic? Clarifying question. Are you assuming that there is a relationship between the TEE and the service provider in all use cases? Because I don't think that's the case in all use cases right now. You want to constrain it to use cases where there is a security relationship between those two.
Just logistically, could you state your name too, please?
Sorry, Stu, S-T-U, Card, C-A-R-D. I can't answer your question because I haven't thought about it sufficiently deeply yet. I'm just saying that there's this notion of rules of engagement that one party provides and that another party may or may not wish to agree to.
Yeah. One of the possible use cases discussed, just to help you think about it, was a case where there's a relationship between the TAM and the service provider and a relationship between the TAM and the TEE, and so it's only indirect. Right. So there's a direct use case, there's an indirect use case. Are they both in scope is kind of the question, yeah.
But I think from the feedback, like I like the sort of the change or the adjustment of considering the service provider being more the trusted application repository in some sense, or a provider. And if you see it that way, I think the answer to your question is whether this is just the device administrator is just a sub category of service provider is where David's comment is no. So
yeah, quickly, I agree with David. I said it's different, but my point is that I say original server provider or use by default definition maybe it's just in scope. Device administrator say it's a word itself. Administer device itself, whether it should be in scope. It was out of scope. I think maybe just it would just handle the TA supply a service provider case.
okay, so we can move on and make those changes. Another topic was we had a discussion on. Or did I do that?
It's not any of these, it's only the projector.
About to get a software update here, huh? Right. No, it doesn't work anymore. Okay. So another discussion we had on the list was regarding the terminology used for keys. So we had trust anchor terminology and root of trust terminology, and then which then evolved into a question about what are the keys actually being used for. And here I copied the table from the architecture document and added some additional, or tried to add some additional clarity on what the different keys are being used for. So we have the DE key, which is really used for attestation. And when the terminology of trust anchors came in, people were saying, oh, you can't use the trust anchor terminology that I actually copied or referenced from Russ's from one of Russ's RFCs, because of the special use of those keys for attestation. There is also this other key pair, which is used then for signing and potentially for encrypting of the software, which is separate to that and also needs to have some keys associated with it. So different proposals on what we should do about it. So Dave came up with a somewhat detailed proposal on how we should distinguish those two terms. Andrew, on the other hand, suggested to just remove the trust anchor terminology, and then we don't have to worry about the distinction between those two. Of course, the trust anchor term is used throughout the document. I thought it was a pretty, I argued that both terms are very similar. I didn't want to go into the details on or have separate terms just because we use the keys differently, because they are described, or the key usage is described throughout the document anyway, including the table that I had just shown. So let me give you a quick glance on what the term is that they proposed. I'm probably not going to read it out to you, but Russ, you want to, do you have, or David, do you have a specific?
So if you would back up to the table.
Sure.
It appears to be the case that a certificate authority is involved in all of these cases.
Yes.
And so if you want to just reference 5280 and say, validate the cert like described over there, you ought to use the words described over there,
yeah,
which is trust anchor.
Which is what I did. That was my thinking, actually.
So I'm not sure that in all, this is Dave Wheeler from Intel. I'm not sure that in all cases you do have a certificate. The table, yes, the table may be wrong, but I may have a different opinion.
Okay.
But I think we need to talk through that carefully, because in some cases, in trusted firmware, I may not have a certificate associated with that key. I also think that we need to make sure that the cardinality here is correct as well, because I think if we have multiple devices, we might have multiple TEE keys, but it's also possible that a TEE may have multiple attestation keys in order to provide anonymity.
Right.
So I think we need to think through our use cases here, and whether they are signed under a CA, and what the cardinality is, and talk through some of those use cases.
Yeah. So the first one on the trusted firmware key, that is really sort of a leftover from what I mentioned earlier. So maybe that should actually not be so prominent in that table or throughout the document in the first place, because it related to the issue that I mentioned earlier. Currently, there's only one attestation mechanism defined in sort of the architecture, which is based on a per device key pair. And that's why the cardinality is right. So it doesn't talk about group keys or other attestation concepts where you ship the same key pair to a bunch of devices to provide some anonymity. Just to explain why the table is as it is. Russ.
Russ Housley. What I think Dave was talking about is whether you validate a certificate or you validate a signature directly with the public key that is stored in the device. That's the trust anchor versus something else, right? Okay. So we address that same issue in another protocol called TAMP, Trust Anchor Management Protocol.
Mm.
So again, we could just grab the same terminology and not have the argument.
Yeah. But actually, currently, the document really focuses on the attestation mechanism is literally assuming a certificate. It's not just a raw key.
Okay, so
Dave.
Dave Taylor. So part of the discussion is, part of the issue is, yeah, you're going to pick one or the other, or maybe both or something, but it's better to pick one or the other. Okay. But because we have multiple communities, regardless of which one we pick, we need to explain that it's the same as what the other communities use by the other term. And so, for example, even in our charter, it says we have to have a good relationship with, TCG and Global Platform and so on. And TCG and Global Platform both use root of trust for X as their terminology. Okay, so whichever one if let's say you choose Trust Anchor, that might be fine to use in the document as long as there's someplace that says, and this is the same thing that these other communities mean by root of trust for X. Okay, and so in that sense, you're using them both, but you're using one of them only in one place and using the other term everywhere. And the question is, which term do you want to use everywhere? And the other one you're going to use only in one place, which is like in the definition or something, right?
And David, I wonder whether it's good to sort of like, very generically refer to TPMs, because many of them, as we had discussed earlier, actually don't allow that functionality we are talking about here. They are sort of hardwired. So any of this is sort of not applicable. So I guess it would be up to someone who's really into that organization to sort of refer to the right terminology to reference technology that actually allows even the use of the OTRP and the update of trusted applications and so on. So
Okay, so I'm going to preempt time because
Okay.
you're 35 minutes
Quick
in.
one. So,
okay, sorry,
Just-
go ahead.
yeah, meanwhile, 2 points. First one about the public key versus certificate. Current document in scope is will require a certificate, right? Require certificate. Purpose of that to say, time do not want too many public keys that are like a trust firmware. All the public keys are managed by a tab. That does not scale. That's the whole purpose. We want to use a certificate there. One can validate many devices. That's one intention. So very important choice there. Second point is about cardinality. That was wrong. That you can have multiple TE keys per device. I think we need to update that one.
So the discussion of CA versus not a certificate or whatever, let's take that to the list since that hasn't been discussed on the list yet. So let's tee that up as a question to be discussed.
Yeah, and also how to support other forms of these. Skip this one. Oh, security domain concept. So currently we have this concept where there's an isolation concept, at least where on the DE side, where trusted applications reside in a security domain. And if there are two trusted applications in that security domain, they are able to share resources. That's sort of like the definition from the document. And there are messages that allow you to create those security domains and then put the trusted applications in there. So the question is that arises is, or that came up is, what happens if in most cases there are just one trusted application per security domain? What is the implication on the protocol exchange? Can we actually get away with having always to go through a separate security domain establishment when you actually want to just have one application per security domain, as it is the case in some technologies. That's something that we still have to struggle with. And that's it. Okay.
Yeah.
More architectural discussion later in other presentations in Fine and in David Wheeler's.
So this is now the protocol part. So architecture may want to change. I think a lot more discussion that is driving the solution document. Right. So just briefly talk about the most part do not need 30 minutes for that one. So just give a quick status update of that one and talk about the changes we made in the work group document, virtual prior document, and a little bit talk about the architecture protocol mapping. It's roughly so far it's consistent, but we're adding more features into architecture as this discussion is see. Then we will accordingly change the protocol part. So I think the driving one would be the architecture. So, but this will give you a quick update that one. So we had a draft approved by work group in March that meeting, then officially get in April, and the minor change, right? Draft name to work group file name and a few comments change on that one. Then we made version 1.0. It's that is when we produce the architecture document, then we'll make a change. It is product documents, take out some content that was too much architecture oriented, and we try to avoid certain overlapping there. And the architecture documents a little more general than the original ITRP. So for that change, that update that one. So here's a quick refresh on like how many people have read the OTRP? This is a draft. It was still the yes. Okay, but several hands. So I have a quick refresh here, right? For people new what it is, right? So even architect document will direct jump in and assume you already know. So but the quick refresh here is originally it's one document, right? It's talking about architecture, design purpose, use case, try to address, and architecture, then the protocol part. So now the use cases and architecture move to architecture draft, like a larger move draft. And this one would retain the protocol part. Really is what's the message protocol is, what's the APIs. Yeah? So undercover, the protocol is a message protocol. Okay, message protocol. Message protocol defines message exchange between TEE and TAM. TAM is a trusted application manager. We choose to use JSON-based message for now. There were other comments or the desire to go to more compressed, more binary message format for this one. So one major choice was that we use asymmetric key and certificates. Okay, with certificates, like I mentioned earlier, asymmetric certificates to make it more efficient for the mutual trust verification between the device and the server provider, which delegate trust through a trust application manager, right? TAM. Okay. Between remote service like TAM and device, you need to communicate. I talked about here. We introduce this agent, right? There was discussion earlier. The name looks different now. We may change it to the broker, connector, or something, right? So that's really the message between device and TAM. Someone may ask why you need such a connector. Just note that many of you may not know. TEE does not have capability to handle transport. Yeah? So, but at least the trust zone TEE implementation, it doesn't know how to talk outside of it. So you must have a application in the rich world, in the normal world, to facilitate that. That's where this is introduced, right? Normal application, like a mobile phone case in Android, for example, normal application, you talk with TAM, you talk with TE, right? Then you need something like that. That was introduced as part of architecture. Okay? And we added one to support transport binding. That means
between TE and TAM. TAM needs some interoperable way receive messages or reach application, installer, whatever, or this agent, you talk with TAM. So what protocol should you use? So we added one, so you support transport layer like TOS and SS and so on. Yeah. So this is a glimpse of the real messages. We have 7 APIs. Okay, each API means some messages. 7 APIs used today. You already, because the first one is a global query. So query what the device state is, how many trust applications running in the device, and what TE it is, and what trust application running, and what security domains you have. After that, it's just a 2 set of management APIs. First one, manage security domain. So security domain is central to the concept of this protocol. It's a create security domain. You can update the security domain and delete the security domain. So when we map to the other TE, like SGX, we also want to think about this concept don't apply what it means that isolation of the TE applications, trust applications. So the major one is about trust application management. That's the main target, right? Eventually, security domain is isolation, but then we have you install trust application. Once you install, you have life cycle. It's really the life cycle management. You install the trust application, update the trust application, and delete trust application. So that's the ultimate goal. Okay, whether you go to SGS others, that's the ultimate one. So you have an application you need to run there. Okay? So that's the really protocol. The part is try to cover the. And this gives you a little bit of scope, right? So you have messages. We define message protocol between TE and TAM. So it's like kind of between TE and TAM, right? Then the message defined, and then we have this kind of called OTF agent. Here, David's point. This is may not be precise word. So this was used to transport. It's really facility transport. So you have some messages from TAM, you need some TE, and you have response from TE, you need send to TAM, right? They kind of there's no connection you can establish. Something here need to do that job. And that's a kind of OTAP agent. We say if you call transport connector, it sounds maybe closer to the what it functionality it is. Right? So this gives a flavor of the message. This is a standard JSON message use. Okay? For API called create security domain request and create security domain response, those will be JSON messages. But the message you need to be signed and encrypted. And the sign and encryption use a standard JSON spec in IFC. Right? There's 2 IFC for that one. Okay, 2 IFC. That's we don't want to reinvent this. It just use whatever in IFC already specified. So just give a flavor how it looks like. Yep. The changes, so just a little bit quick one here. It's a remove general architecture specification to the architecture draft. And we changed the overview part. So the protocol part change was we adjusted the instruction part with a little bit change, overview and instruction change. So now we say that follows the architecture draft. Right? That's some document update for that. Not really, really protocol change. We refer to terminology. We moved out to the terminology section because we only have one-to-one. Architecture document, we define that one. We reuse the same terminology. We will not repeat it. But we retained this entity relationship and key type of sort because that was and has been what the OTRP used as a solution, right? And architect document also refer to that one. We will see. These two will be consistent, right, with terminology and architecture realization. Talk about. So there will be no API level change and no message change because that was the core protocol part. There's no change. More about the document compliance. But one change was about trust firmware part. So as requested, it should not be required. So now we'll make it optional. Okay. What's optional now? TAM has a decision to make today. Say you receive a message from TEE. For TEE, it may optionally include some assertion about that trust firmware or that firmware, not trust firmware. So it may decide are trusted or not trusted, but that is a backward compatible, also can support other cases. Then we also have some cleanup of the terminology. One thing about this circuit boot module, and Dave gave the comments that we have two there, they do the same thing. So we just keep the one. Okay, we choose to use the trust firmware. This ones I think architects talk about it. I will not repeat here. So these are there's gaps today because new features about multiple TE support, TA boundary distribution by client application. This has not been designed in the OTP protocol yet, but we will continue to work on the architecture. What's the resolution for that one? Then we'll put into the protocol part. So this is more for that one. We have some idea here. Let's discuss how to support multiple TE. I think I will leave that for Dave because Dave will also talk about his slide diagram, right? How to facilitate multiple TEs, type A, type B. He already explained. I don't know what repeat this one. Boundary distribution. There was some Hannes talk about right challenges. We went to the trusted application boundary inside the client application. There were a few challenges I already repeated. I don't want to repeat here. But once this was discussed, we'll put in the protocol because there's issues about the life cycle management. Not the first one. It's after that, how to manage that security domain or how to update the trust application and so on. And then how to handle the agent part. So this will be continued work. I would expect the next revision will cover more in this aspect. So, yep, that's about it. Yep.
Okay, this is Dave Thaler as an individual participant. Nancy's the chair over there. So at Hackathon, there was no Teep stuff like pre-prepared or whatever, but since I was at Hackathon, I decided to use that as an opportunity to say, what would I need to do to implement OTRP? Could I do it just by looking at the spec? And so I started that. Of course, I didn't get very far, but I got far enough to generate a bunch of issues. I should mention that I already have experience in writing trusted applications for both Trust Zone and SGX. I've done both. In fact, I've done business logic that can be compiled into both an SGX enclave and a Trust Zone, so I understand both issues, and so I was writing code to try to be as not agnostic as possible, but I was doing it on an SGX-capable laptop. Okay, and so I didn't have Trust Zone hardware in hand, I had SGX-capable hardware in hand. So anyway, so this is a hackathon report where I was the one active coder there. There were other Teep people in the room. Hannes was sitting right next to me, and Nancy was just within earshot, so so there were several Teep people in the room, but I was busy coding. All right, so anyway, I sent to the list a list of 10 issues. I'm not going to go through all of them because at least one or two of them David Wheeler is going to cover in his presentation, but I'm going to cover some of them. And so I'm just going to show up there what they are, and I'll focus on a couple of aspects in there. Okay. So the first one is that the first step that happens, and I'll show this on the next slide, is that something reaches out to the TAM to provide it here's the TA that I need. The OTRP document does not define any message syntax for doing that. In fact, it implies that it's not part of OTRP, but it's ambiguous. So I couldn't actually implement the first message in the exchange. So I made something up. And you'll see that on the next slide. Right? I made something up that actually does not require that message because it doesn't say what it is. Right? Okay. So the second issue, and Dave is going to talk about this one, is the TAM needs to keep track of what TAs are installed. And so I'm not going to talk about this in more detail because Dave Wheeler is. And we keep saying Dave's going to cover this. Sometimes people meant me, and sometimes people meant Wheeler. Okay, so the third one is there's an extra round trip. And so I discussed this in the list, and that's where I'm going to get to my slide here. Okay, this is what the draft says. Okay, step one, this is an example flow. I found the example flows section to be extremely useful. I could use that to say, here's step one, step two, step three. This is what I'll implement. Okay, what it says is that something it gets a hold of the TA or the reason. So step one is not a protocol thing. It happens sort of out of band. You figure that out, right? You now know that you need to install this rich application, and it depends on the following TA. Whether it's bundled or not, it gets the metadata. Okay. What then it says, I reach out to the TAM. I know which TAM it is based on metadata or whatever, and say, I need TAX with no syntax defined. Okay. This is not an encrypted OTRP session. It's an unencrypted, unauthenticated, untrusted message. At this point, the TAM can now reach out to the OTRP client using an encrypted, trusted session that goes between the TAM and the TEE that says, hey, what are you and what TAs do you have? And the response in the step 6 is, oh, well, I'm a foo TEE and I have TAs A and B. So there's these 3 messages that at the end of the day, this is used to figure out that there's a desire to install TAX in the foo TEE. And so that's one issue, is that there's 3 messages, and whether you have, well, here it's inferred because I need TAX, well, I have A and B, I didn't see X in this list, therefore I need to put X in you, okay? And so there's work on the TAM to say, take this and see if it's in this list, okay? And then secondly, this notion that the rich app has to be running, and the rich app has a TAM transport. It does not say that that's mandatory. That's just how it's described. And so one can infer that it's mandatory because it doesn't say. So this is what the draft says. As an implementer, here's what I wanted to do. What I wanted is I wanted there to be something like an app installer, like an app store thing that talks to Steam at the Google Play Store or the Xbox Store, whatever it is, that goes and grabs stuff and gets manifests. And that has the facilitator code in it, so that the rich app doesn't have to be launched if it is going to fail because the dependency is rejected, okay? And so what I wanted is I wanted one message that says, I'm a foo and I need TAX. So here there's a different flow. That's what I wanted, where I wanted the facilitator piece in here to start by saying, hey, OTRP client, I have a dependency on TAX. This thing can then initiate in the other direction. So in other words, the first message, OTRP message, goes from the OTRP client to the TAM, as opposed to how it's defined right now, where the first OTRP message goes from the TAM down to the TEE, right? And so it says backwards in terms of the first message. Okay, this is what I wanted to implement, but I couldn't do that in the current spec. Okay, and so what I wanted was one message instead of 3 to get the information. This doesn't have the problem that David Wheeler is going to talk about, which is I have to keep track of all the installed TAs over here. It doesn't have that as a requirement. And if he says reject, then there's no reason to even launch this rich application in the future. I don't have to worry about installing the rich application if the metadata says that dependency is a hard dependency. Okay, so that's what I wanted. I couldn't do that, but this is my use case as to what I wanted to implement. And so I started implementing the closest thing that I could, and that's where my comments came from. Okay. Next couple of issues. I mentioned that OCSP stapling data, there's no normative reference. I'm not an OCSP expert. I didn't know where to look, and so I skipped this part. I'm saying, remember, the task was, could I implement it from the document, not having any extra knowledge? And I found, no, I couldn't do that. Okay. The next one, I'm not going to go into much details other than there's this field that says that it is there to make sure that the message was received by the right device. So the OTRP client and the TEE parses it and said, does this have my device ID in it? If not, it must have been destined for the wrong person, the wrong entity. And to me, this seems redundant because it came from a TEE across a session or whatever that could go away, I think. But if it can't, then it seems to be missing from some of the other messages that Ming had on his slide. And so that was a point of confusion in the document. I wasn't sure exactly how to deal with that. Okay. The next one, I think Andrew responded on the list that there's some blue Boolean-ish fields that are defined as strings. And Andrew pointed out on the list that actually the document itself was internally inconsistent. In some places, it says the same field is of type Boolean in JSON. In other places, it's of type string, quote true, quote false, even for the same field. And Andrew said, yeah, that was an oops. But I wanted them to be Boolean types, not strings, because if you do allow CBOR encoding, Ming mentioned that it was JSON right now. There is an individual document that's the CBOR encoding proposal. I think I don't know if it was from Carson or whoever else. If we go that way in the future, then having it be a type gives better compression. It is implementable except for the point where the same field is discussed as being contradictory in 2 places. Okay. Okay, the next major-ish issue, one worth drawing a picture anyway, one that I want to talk about is number 7, which is this extra round trip to create a security domain, right? I mentioned before the extra round trips necessary to initiate it, right? Where I couldn't implement the first message, right? And so I wanted to have a diagram on that one, and I'll come back to number 8, which is also worth mentioning. So here's what the exchange says right now. The TAM says creating a security domain, and it comes back and says, okay, here's a key that you can use for subsequent operations. And then the TAM says, okay, I'd like to install this TA in the security domain. Here's the key that I have for this thing. And it says, okay, done. There's these 2 steps here. Now, in the common case, there's exactly 1 TA per security domain. That's not the only case we care about. It's just a common case. Okay. In other words, because the security domain is providing isolation among TAs, like Hannes mentioned on his slide, right? And so if every TA wants to be isolated from every other ones, including ones from the same author, right, then you want there to be a separate security domain. And so this notion that every time I install one of these, I need to create a new security domain is 2 messages to do the same operation, which is to install stuff. And so I said, wouldn't it be nice if I didn't need to send this message? It could just be done by sending this message. Because if you look at the inputs in here and the inputs in here, they're exactly the same things in that message, the only exception being that did field that I was mentioned on the previous slide that I found confusing. Okay. And so I said, could you optimize this out to say the first one of these does this as a side effect? If it isn't there, create it. Okay. Could that be a side effect for optimization? Again, that's still backwards compatible. You're just providing an optimization that says, if it hasn't been done yet, do it as a side effect. So we had this exchange on the list where I think it was Andrew was explaining, oh, but this key that you're getting is the main thing, okay? Because what this key lets you do is if you choose to encrypt the TA binary or the data associated with it with information that is unique to that device, like only that device can decrypt, here's the data that goes with it, okay? Then this key is useful here. So he was saying, if there's encryption, okay? So first of all, encryption is not mandatory, so there's 2 cases, okay? If you're not using encryption, then of course it's redundant information, it's just an extra round trip. Okay, you can implement it, yes, it's just inefficient. I didn't like it, but I could implement it. Okay, so it doesn't carry additional information, and it's just less efficient, right? So it could be done. So let's take the case that he was talking about, where you require encryption. So the key that you're getting out of Create SD right now is a different key for each security domain. The architecture document explains that the same security provider can have any number of security domains. Like if you have 5 apps in the device, you could have each one have its own security domain. So I'm the security, the provider. I got 5 apps, and therefore I have 5 security domains because I want them to have memory protection from each other. Okay, that's my choice. And so how many keys do I have? If I create a new security domain for each one, I have 5 keys. If you go back to that table that we were commenting on with Hannes and Russ and I, it was labeled as a service provider key, not a security domain key. So what's the granularity here? Is it 1 key for security domain where there's multiple per service provider, or is it just 1 per service provider? So I claim that bundling the notion of the service provider key into a per SD message is not the right granularity. That was my conclusion in thinking through this, okay? As it may not be the right message to do that operation in, or maybe we need some other variation of that exchange. I don't know what the answer is. I'm just saying that was the issue, is that I ended up with 5 keys, even though the architecture document or the table says they all need 1. So it's mismatch, okay? And so my recommendation is don't convolute key creation by the service provider and isolation boundaries. Those are 2 separate concepts. Don't use security domain to do both purposes. That was my recommendation as an individual participant to the group. Okay. There's ID fields that are underspecified, and I think even Andrew agreed, yes, they're underspecified. It just says they need to be unique. It doesn't say what they have to be unique within. Do they have to be globally unique? Do they have to only be unique within a particular session between the TEE and the TAM, right? For example, can I use a sequence number or not? If I use a sequence number, it is not globally unique. It's unique within my session. It didn't say. Right now they are strings, and Andrew said, oh, well, that means you could use GUIDs. If you need global uniqueness, this is good. You can use GUIDs. If you only need per session uniqueness, extra complexity that's overkill, tell me I can use a sequence number. Okay, the document doesn't say right now, so I didn't know how to implement that. And so that's kind of where I started saying, what do I do here, and making a guess, and which could be wrong. Okay. So if it only needs uniqueness within a particular session, integers would be much more efficient, but that's something we should collectively decide is what's the intent of uniqueness for the request ID and the transaction ID. I could not, as an implementer, think of a reason why an integer would not be sufficient. Okay. Andrew seemed to think that GUIDs would be useful, but I can't think of a use case for uniqueness beyond a session. So if there is one, let me know. Otherwise, as an implementer, I would prefer an integer here. Okay. Come on. And then lastly, this was an editorial issue. I found it confusing that this, what looked like the same thing was referred to by two different strings in here. You can see the only difference is the TEE and TBS in the middle of it. There was an explanation. I think it was Ming posted the list that I didn't understand at all, so I still don't understand this one, but this is purely editorial. There's no technical issue here. I could implement it no matter what. I just found it longer to implement it because I had to flip back and forth between places to figure out what it was talking about. And then lastly, this one is kind of architectural specific as I was thinking about how to arrange code. It is unclear in the document, at least in the places that I could find when I was looking at the time, whether a rich app is allowed to depend on two A's from different TAMs. My hypothesis is yes. And whether a TA can depend on another TA, including one from a different TAM, where my hypothesis was yes. Now, since then, I think Ming or somebody else posted on the list that there may not be a use case for that or whatever. And so I wanted to comment on that because this is, I think, my last slide here. That when writing, forget trusted applications for a second. When writing applications that are distributed in various types of app stores and things, it is not that uncommon to have a dependency on something that has another dependency. Okay, this is not uncommon. My claim is that the way that the more trusted applications that get developed, the more and more likely it is that that same model will translate over for the same types of reasons as people do it for the rich application dependencies. Okay, so I fully expect this to become common, even if it is not common now. I don't think the protocol has to change significantly to accommodate this. So I don't think it's a showstopper to say that, yes, a TA can depend on another TA. It's just another way of expressing dependencies, right? Okay. But again, the expression of dependencies is outside the scope of the protocol. So I think the existing protocol messages can be used to do that. Okay, there we go. I think that's my last slide. Happy to take any questions. Otherwise, I'm going to pass it on to David Wheeler to talk about SGX implications. Yeah. How are we doing on time?
We're doing fine.
Doing fine. Okay, great. That means you can take whatever time you want. But yes, if
Just,
there's
do we
questions
need
or
to-
comments,
Would you clarify on the mailing list, or we'll do a little bit quick response on these 10 issues?
I'm not the chair for this discussion, Nancy is. So
Nancy, now,
how much time?
Yeah, so how much time?
How much time before David gets to his allotted time if we have questions
we have-
online?
Yeah,
we have
so
50 minutes
we-
left.
We can,
Okay, so if you
So-
have questions on my stuff,
yeah. So
We have time, it
you've
sounds
got like 5-10 minutes,
Okay.
and then we can
Okay.
use the rest of the time. I mean,
Okay.
I'd like 5 minutes just
Okay.
to close.
All right.
Yeah, go
some of
back.
so if you want to go
Okay.
back to these and discuss these now is a good time.
Yeah, I want
Yes.
quick,
Okay.
quick
Yes.
some comments here. So if you get an audience, a lot of audience, good to
Yeah.
share this mailing. And
Sorry.
then start from, backwards. Yeah, let's from 10, go back to 1.
This one?
Yeah, no, from 10. Like, no, out backward.
From
because-
10,
Yeah,
sorry.
yeah, refresh from that.
There.
Okay, now, last one. Okay.
Okay.
Yeah, last one. That was, I think that it's a one. It was like Andy or Andrew Andy. We call
Yeah.
him Andy. Okay. It was not in original scope, right? Multiple TAs chaining relationship. So now a TA install another TA. That was not
Not
in
in
scope.
scope.
So we'll address that. I think we need to discuss offline.
yeah,
That because
yeah.
a little bit of scope change. On the 9, it was a reply to say a device may have multiple TEs. So get a device state response consists of a list of get a device T state TPS response. That was a relationship.
Okay.
One to N. Okay. One is a list of others. Okay. That just clarify
okay.
concept.
I did not find that clear in the document, so this is
Okay.
number 9 is purely editorial.
Yeah,
I had to
editorial,
squint at it
okay,
and stare at the
okay.
pages for a while.
So I think Andrew is on the line. So
On
let me
Miteco?
see.
Okay,
Eddie,
great.
yeah. Hi, Eddie.
Hi, can you hear me?
Yep.
Yes, we can see you even.
You're up.
So firstly, thanks to David. It's really important that we get feedback from people working with the protocol to raise these issues. I do want to cover the point about the encryption of the TA being optional, which I think David, you were saying that TA encryption was optional, and for the case where it wasn't required, the message protocol could be shortened. I believe right now in the protocol document, the TA encryption is mandatory.
Yeah, okay, continue here. Okay, let's just jump on this issue. Okay, so today, yes, I think that's David, you made a good proposal. I think there's an optimization case. Before the current problem was Zoom,
Right.
the very value proposition, a TA binary itself, it will be always encrypted. So that when pass from supply to TE, no man middle, including any client application, should never see the binary itself, so that they could reverse engineer.
So
However,
that is a valid use case. I don't know why that should be
I
required for
understand.
everything.
So the in
Signed,
case,
yes.
right?
Signed, yes.
Some use case they don't care.
Yeah.
Then we can bundle it. Then maybe I think they will leave an option here. I think that's for that one.
But perhaps we should be clear on what encryption means, confidentiality or integrity.
This is
or
the
both.
binary itself.
So-
Both.
so-
The
Both.
binary itself cannot be read by an intermediary, is the case. that
That's
we're
right.
talking about.
So
Right.
confidentiality here.
Confidentiality.
Okay.
Confidentiality of the code.
Can I go back to the issue 8, 7, or I just quickly comment each one.
This is the one that was. This
Yeah,
is the
yeah,
one
that
Andrew
was
talking
Andy is
about.
talking. Yes.
Yeah.
If you know encryption.
Okay.
Yeah. Okay. We'll talk to this one. Go back, roll back one more slide. 8 to 7.
Which one? 8, 7? Okay, there we go.
Yeah, 8 to 7. 8. Uniquely, yeah, those ones actually Andy also comment online.
Yeah.
So that one's more consumer within the TM itself to track this request are sent when next in the session. Next response come back to you, I can link myself. So really unique within time. So
That was
that's
how
why
I
we don't
read it.
make good, but we can
Within a
change that.
session, right?
Yeah, within a
So if
session.
I got multiple
Right.
sessions to the same TAM, it's only unique within each
Right.
session. Yeah.
And I go comment to the 7. Okay.
Yeah.
7. So today there was a design purpose in the beginning. So when your application says I want to install TA, maybe TA already installed in a device.
Yes.
So it is an upgrade or it's a new installation. That's why it make a round trip to TAM first. TAM said, tell me, do you have the TA already not? If you do, it's upgrade, not installation. So that was the
You
intention.
said TAM,
said,
I think you meant you asked the TEE what's in there. You said ask the TAM.
TAM. I said, no, TAM. In current one, because the current one is a client application, talk with the TAM first. Say, I
So
want
the
to
TAM
install.
doesn't know.
The TAM's not-
TAM initiate the first request, get device state. It asks TE, tell me what TS you already have. If you already have the TA, I will send a command say update TA, not say install TA. That's why that was get device state was always the first call. Secondly, other than the upgrade versus new installation decision it make, there's also integrated part. There may be multiple concurrent sessions. TA already installed in middle of it. I do all because of some second attempt. Then if you send a command, it's not installed, it should be upgrade. So that way the clean state is important for TAM to know. It doesn't need to maintain, it doesn't have to store it, but it need to ask for it.
So
Because we have a new device. That was a design intention in current protocol. Just to clarify.
Right. I think the most important thing that you said is it doesn't need to store it.
Store.
Meaning
No.
it needs it within the
it
context
does
of the
not.
exchange, but it does not have to retain a list.
That's right.
That's where what the document says is different from what you just said. And I think the way that you phrased it is better. And David Wheeler is going to talk about for everybody else why that's the case.
Yeah. I think they have it just to clarify the
Yeah,
why
yeah,
there's a
yeah.
question pop up, right?
Yeah.
Came up. Say, okay, I think that ask that one.
Okay.
6. Okay, the second one, that's an editorial.
Right,
5,
exactly.
that's unique identifier. It's a device. DID is a device identifier. It's a hash of the device certificate. So we know it's always receive this one, send it back the same thing. To quick match, it's optional value, by the way. It's optional value.
Right. My main point was either it should be in all 7 of those messages or in 0 of the messages and use an underlying identifier for all 7 of them. I don't care which, but it seems odd for it to be in 1 and not 7.
Yeah, it's optional. Okay. 4, yes. I think we need a normal reference there.
I think Andrew already answered, one of you guys already
Agreed.
answered number 4.
Yeah,
So
okay. Can go back. Yeah, this one. The diagram extra round trip.
The main thing to talk about is this diagram right here. Do
this
people
one.
think that this is
Yeah,
a
this
useful model for, do other implementers
Right.
agree that this is a model that they would like?
Yeah. First one, I like the concept here is to have an installer. As an installer, that's actually good ones that application solve don't need to do the job. It can be delegated to some installer. It's a more centrally managed device. But undercover, I think concept, the product part is still there. You need facility to talk with OTRP agent client, talk to TE, right? The job, right? The installer does job for the client application, right? It's just a more better management model or another option. I agree with that one.
So that's why I'm not trying to say that everybody should use Model 2. What I'm trying to say is that as an implementer, the document is written for one, and I wanted to use Model 2, and I wanted a document that would allow me to use Model 2. I don't believe I'm asking for anything that could not be perfectly backwards compatible if you had an existing implementation, right? I just mean that you would be using different message or be using optional fields. You'd skip some messages like create SD or whatever it is. So.
Okay. Yeah. And then, okay, go back one more slide. What's it? It's just here. No,
the existing one? This one?
Yeah. One. You say we lack of syntax. That one interesting one. I think we, as an open discussion,
I am fine with no syntax defined there because I would prefer a model where I didn't need that message at all, right?
Right. Do we need a message, right? What the TA? What's it? This is I'm app X need a TA, right? I'm a fool, right? I need a TA from this TE. So now that becomes new message.
Correct. I would
do we
like
need to define or not?
I
think that's why.
The difference between this line and this line where there's no syntax defined is only the fact that this one is an OTRP message that is signed and originates in here, as opposed to one that is the untrusted one. I'm saying I don't care about the syntax for an untrusted one. I think there should be a new OTRP message.
That was assumed that was left to time providers. They manage their relationship with their client. That was the original scope side. But here,
so the transport session, which is not shown here, it was on your slide, on the slide we had earlier. The transport session in general has to be initiated outbound. Right? Because there could be firewalls and stuff here. It's only outbound will work. So that means if the connection is outbound here, it's not a burden to have the first message be in the OTP client to the TEM if a message were defined. So it should be as an implementer for reasons, including the ones that David is going to talk about earlier or later, because I don't want to steal his thunder, which I have the same issues as he's going to talk about, right? Because I mentioned I was doing this on an SGX capable laptop and wanted to work for either. I wanted this message and couldn't find one. So there you go.
Yeah, now go back to the first slide.
Okay.
So I think when we talk about the individual, put the numbers together. Okay.
Yeah, don't talk about two. That's the one that's in the next presentation.
Yeah. Number one.
That's what we just talked about. Number one is what we just talked about.
But when we talk about this encryption, say they have different. You talk
about
secret domain. Which one?
Encryption was the one that Andrew was commenting on.
Multiple. Oh yeah, create SD.
This one.
Oh yeah. Two. Okay. Document I just read here. What document just assume is that we don't have a separate encryption key per SD. It's a per SP, like a per service provider. What it says is this value, TSP AIK, anonymous encryption key. It's a newly generated one. It's on first secure domain creation. You generate SP encryption key and send it back to TAM. In future, second secure domain, you don't need that. So you already know it has that. So that is the current document. So it's not required to have a separate one.
So I think we need to move on. So before we start with David, I just wanted to call out a couple of logistical things. So no, I don't need that. You can give it to Dave. So given that you've listed out the 10 issues, right? So I think we need to start keeping track of this. So my suggestion is to start a GitHub, put the documents in there. David Wheeler has also volunteered to help be one of the editors for at least the architecture draft. We can talk about the solution draft later. So unless the group objects, and I'll announce this too in the email, we'll start tracking the issues and put the documents on GitHub. All right? Okay, so with that, let's keep moving forward.
Great. So my name is Dave Wheeler. I'm from Intel. I'm going to talk some about the issues in looking at Teep in SGX. I'm not going to satisfy all your curiosity about SGX. There's some references. These are posted so you can go look more about it. So I just ask if we maintain our questions focused on Teep. I'm going to talk a little bit about what SGX is and then talk about some of the problems from that perspective with Teep. I'll talk about the trusted computing base and how that has impacts to Teep, and then I'll talk about attestation. I've got some other slides too to talk a little bit more in pictures about some of the flows, which I think will help more of the conversation. So I'm going to go through these first ones pretty quickly, and then we can have questions over the pictures because I think it'll be easier to talk through that way. So SGX is very different from trust zones and perhaps other TEEs. Instead of having some sort of kernel or something like that, all SGX is really some enclave page cache, some encrypted memory. And what an application does, an application includes the enclave code and then loads that through some processor instructions, e-enter and or e-create and things to actually create the enclave. And so that enclave is actually part of the client process. The operating system manages the page tables, but can't do anything to them because they're encrypted. So it's one process, and for one enclave to talk to a different enclave, there has to be some special things going on. So when an enclave is launched, the application executes an instruction that talks to a special platform service called the launch control. And that does some integrity checks on the enclave itself to make sure it's properly signed and with a key that's signed by the launch key. So all of this is kind of very different flow than what Teep kind of talks about from an ARM perspective. So the first piece is the trusted application isn't separate from the client application. So typically when we deliver an application, all the TAs are bound into it. And you don't have to go searching for a TA. TAs don't get installed separately from the client application itself. Now, it isn't the case that you couldn't change that, because a trusted application, it acts just like a DLL. And so you could have the DLLs outside of the application and actually install them. But the enclave doesn't exist until the code is actually loaded. So there isn't something for me to go ask and say, hey, do you have this TA, or is this TA loaded? That really is a non sequitur in SGX. There is no security domain because we don't have a large TEE that we're separating for applications. A TEE is basically instantiated in memory for a particular enclave. So you could consider that a security domain of one, but I think we need to talk about what are we trying to get out of security domains, and I'll talk more about that a little later. And so there is no really internal agent watching all the enclaves. I don't have some registry somewhere where I say, I've got these 27 TAs installed somewhere on my platform, and these 3 are currently running. There isn't really that concept. An application can have one or more enclaves running within its process, or it can have none. And one enclave isn't aware of what other enclaves are particularly doing. So when we talk about install and uninstall, that really doesn't fly in the SGX world. There really isn't an install or uninstall command. Dave Thaler and I talked about some options for this. His perspective was it's kind of onerous, I guess, in current SGX to go get your application signed. You've got to go get a key from Intel and get that signed by the launch key. We're working to make that a little easier. But this concept then of I've got to have a key that allows me to operate on the platform. And if I have different platforms with different keys, then that can become kind of interesting. That's where a TAM might come into place and might be very useful, so that I don't necessarily have my TA signed for that platform. I use the TA to do that. So I say, hey, TA, I want to run this, or TAM, I want to run this TA. The TA will sign it for you and return it back, and then it will be able to launch on the platform. I thought that was a really interesting idea. There also isn't really a start, stop, or things like that. The client application has control of that. So let's switch a little bit to SGX, the Trusted Computing Base. And this really goes back to some of the things we had talked about on the mailing list. We're not tied to secure boot. So the perimeter on your right-hand side, you can see what SGX attack surface is. It's really just the hardware. SGX is implemented in microcode in the CPU. So its security perimeter is the CPU package. All of the memory, if that's off package, is encrypted. So that's outside of the boundary. The BIOS and any of the secure boot is also outside the TCB. It's true that the BIOS does set up the memory for how much memory you have in the enclave page cache. But the only thing that the BIOS can do is not give you memory, so it's a denial of service. It doesn't have control of the keys or any of that. The OS is also formally outside of the TCB. It does control the page tables and things like that, and can do denial of service, but it can't actually do anything with your data. So again, we don't really depend on secure boot, and in fact, if you're using SGX on a platform, you may not even have secure boot turned on. So to go ask for a measurement of how your platform was booted, it may not even be possible. SGX has its own trust roots and its own keys for verification and measurement and so forth. So now whether secure boot is on or not, that's maybe more of a personal decision. And a TAM, as Ming pointed out, I think it's a good idea to make that optional. And then a TAM can then make the decision, do I really want to run my application on this platform if it doesn't have secure boot? And I guess as another point, what I'd like to do is talk more about maybe using EAT tokens as a way to give us more flexible attestation capability in Teep. And then allow the claims to then be decided upon by the TAM and say, hey, I'd like to have this kind of token with these kinds of attestations. And then that would give us some more flexibility, I think, going forward. But whether we want to tie those things together is something we can discuss. So the last SGX set of slides here is on attestation. There's two types of attestation that happen with SGX. There's a local and a remote attestation. So between two enclaves on the platform, I can do an attestation between them, and that uses an AES CMAC key. So it's just like an HMAC construct, and the CPU is really the trusted entity between the two enclaves and provides measurements between them, so you can have two enclaves set up a trusted channel or share data or whatever. If you want to do an attestation outside of the platform, we call that a remote attestation, and that uses an algorithm called EPID. EPID is an elliptic curve group signature algorithm. I have another slide to talk a little bit about that. But what you do is an enclave would do a local attestation and then provide that local attestation outside of the TEE to the rich app. The rich app would then submit that to the quoting enclave, which has access to the EPID key. We don't give access to the EPID key to any application, right? Because it's kind of a sensitive capability. And so then the quoting enclave would then take that local attestation and sign it with an EPID key, and then that can be used to get verified off platform.
Hi, Dave. This is Russ. Just clarification question. Your AES CMAC obviously is a symmetric thing. I'm sure you did that for performance reasons. Understand that, but are these pairwise keys, or can there be 3 cooperating using the same key?
That's a good question. That's an SGX specific question, so I'll answer it very briefly and then remind everyone I don't want to have those conversations here. So each enclave gets keys derived from some internal parameters, and then gets a symmetric key that's unique to them and their state. When you pass that report off to another enclave, what is included in that report is information about the enclave who sent you that attestation. And then that information is then passed to the CPU, which creates that key or verifies that key for you. So the keys, the symmetric keys are unique.
So neither enclave really has access to the key itself.
Correct.
I got it. Thank you.
Yeah, otherwise you have a forgery issue. Yes, absolutely. Okay, so what's relevant to Teep? I think the primary thing is, as we look at the crypto, in order to be able to do attestations to a TAM and outside entities, we need to be able to support EPID as an optional algorithm. I wouldn't say that that's something that we need to have mandatory, but for TAMs and TAs and service providers that want to interface with an SGX, they need to support EPID in order for us to do that. We could look at the local attestation as a way to simulate security domains, depending upon what security domains function we want to actually use in the protocol, other than just pure separation. I'm going to just quickly say these are the patent rights about EPID. You can look at those if you're interested. I've done my best to find out information, but I haven't gone through all the legal stuff at Intel to say that this is completely accurate, but it's the best information that I have available right now. As we also look at crypto algorithms, one thing I'd recommend is that we look at post-quantum. I know Intel is is trying to make sure that all of the products and things that they're pushing out are post-quantum secure to the best of the NIST recommendations. I listed some algorithms down here based upon some reviews. I changed some of the things that we talked about at lunch the other day, and adding in the EPID group things. Obviously, that's something that we can discuss more on the mail list. So let me transition more into some pictures where maybe we can have some more conversation about this. So out of these things, with some of these SGX idiosyncrasies discussed, what's relevant as far as Teep services goes, right? So if we had Teep on an SGX platform, it would operate quite a bit differently maybe than some of the flows that are currently described. The Teep agent's counterpart inside the TEE would have to be an enclave, just like any other enclave. And it wouldn't really have this omnipotent universal knowledge about what's going on inside. So the only thing that it could really do is a best effort. If applications cooperated with some REE service that was the Teep agent or broker or whatever we end up calling it, then that agent could respond out of the enclave to a TAM to discuss what's probably installed and what's probably available. But really, because of the way that SGX is normally packaged today, that may or may not be real useful. The most important information that would be, hey, how much memory has been allocated to to SGX? How big is my page cache? Because I don't want to have 128 megabyte page cache and trying to download a 200 megabyte TA. But so there might be some things that are limited, but what I wanted to, let's see, do we have the other? Oh, this is not the latest set of slides. It doesn't have any of the pictures in them.
Is this the last slide?
Yeah, this is the last slide.
If I disconnect the projector, I can,
Okay.
you want me to do that?
Yes, please.
I forget the PDF. Dash code one. Oh, okay. Then I may not have it up here. Do you have that next? Can you put it up here? Okay, if I can do a. Sorry, go ahead. Is the right version uploaded online?
Yeah.
Then I may be able to just open it right from there. I don't know if it's
No, there should be a picture.
okay, no, it's O2 that's not mine. Right, keep going. I can present now O2. O2 has. Yes, that's it. Okay, then I'll use O2. Is if this is sufficient, we'll go with this is sufficient. Okay.
Oh, no.
It's-
I did upload version 3.
Yeah, it is. It's just listed
It's,
as up to.
the response change.
Okay. Oh, I see.
Because the image one.
Okay. Yeah, so let's go to then slide 14. Okay. So, sorry for that, folks. The right slides are online. So we've talked a lot about sort of how applications are packaged. Could you can you expand that a little bit? Just zoom in or?
Not because this is the PDF I'm looking at, right?
Yeah. Go up to the toolbar and do the plus.
Ah, yes. There we go.
That's much better. Yeah, that's good enough. Okay, so we've talked a lot about how TAs are packaged, and some of this has to do with how they're signed. So I spent some time, thinking about this from an SGX perspective, kind of folding in some of Dave's ideas and things. And so as I look at this, or as I think about this, I see kind of 4 quadrants. Along the top, I've got my TA packaged with my client app, and on the left-hand side, the TA is fully signed. So it's got the right signatures for the TA to actually be able to be deployed and run on the platform. On the right-hand side, the TA may be signed. It's signed by an SP or a developer, but it doesn't have the right signature for the platform. And so this is where it might be interesting to be able to, for the rich app or for OTRP, to be able to send that bucket of bits that is the TA and say, hey, can you sign this for me so that I can run it on this particular platform? Along the bottom, you have sort of the more common ways that we've been talking about TAs, where they're separate, and you could have the same kind of situation as well. Oh, okay, next slide. All right, so in the case where the TA is packaged with SGX, you would install the application by some means, whether it's a USB stick or something like that. You get that onto the application, and then the client application has to run, and it would have to talk to some Teep agent or broker or something and say, hey, is my TA properly signed? If it is, then the application would just load it and run it. And there's no need for TAM interaction. The Teep agent could do sort of a courtesy registration and say, okay, now I know I've got this TA that's running. There's no really security domain. Maybe it's a security domain of one if we choose to look at it that way. When the client app goes away, the TA goes away. If it crashes, the Teep agent may not even know that it's gone. There isn't really an uninstall or an update or a delete TA because it's very ethereal. It goes along with the client app. So go ahead to the next slide. But what if the TAs weren't bound to the client app, or we chose to treat them that way, right? Then we could use Teep as sort of a TA registry, which is more in line with the way that I think Ming, you've been looking at it, right? And so the client apps could ask for a particular type of TA in the platform's registry. This would have to sort of be done through an untrusted interface, and one of the things that's leaving me a little uneasy is when I get that TA back to the client app, how do I know that that untrusted part of the Teep agent didn't lie to me? You know, maybe the enclave gave the right bucket of bits back to the Teep agent, but the Teep agent lied because it doesn't like me, and sends me the wrong bucket of bits. So the client app, and this is an issue because the client app is the one that has to instantiate it, right? In the trust zone side, when you ask for a TA, it gets instantiated by a trusted agent inside trust zone. But in SGX, it doesn't work that way. The bucket of bits kind of has to come out and then get put back in. So let's go to the next slide. So the way I kind of thought about this is, so you install the app, and then in step 2, you say, hey, I need these TAs, right? And so I showed that I've got some dependency. It's probably a manifest that's signed or something like that. And that would go into the Teep agent's enclave. And then that Teep agent enclave would go and talk to the TAM. Now, obviously, that does have to, I didn't show it here because it gets a little crazy. It would have to go back out to the Teep agent, and the Teep agent would have a socket, right, out to the TAM. And then that TAM interaction would either get assigned TA if it wasn't in the registry. The Teep agent, the enclave, could maintain a registry of TAs, just like we do in Trust Zone. Whether we want to do that or not becomes interesting as we talk more about, you know, normally the SGX enclaves are tied to a particular application. And that's because keys and secrets and things like that are sealed to the enclave. So if we share, if Hannes and I share a TA, then or an enclave in the SGX case, then I can see Hannes's keys and misuse them because I'm an evil guy. And then I could, you know, sign him up for a big debt or something like that and get the check. So there's reasons why we probably don't want to share TAs that way, and that's something we can talk about as we move forward. But if we did that, this would sort of be a way to allow that to occur. In this case, then, you know, uninstall and update and delete of TAs actually makes sense because you'd be talking to this registry. I still think we have some sort of issue with return when the Teep agent enclave returns the in the last step returns the TA to the untrusted app or the client app. It has to go through the Teep agent, and that's where the TA could be attacked, and that becomes problematic. Not so much that the TA itself could be changed because the integrity will be checked on the load by SGX. But if I don't know what specific TA I'm trying to get, it might have other functionality in it that would allow someone else to do something that I don't want it to do. So we have to sort of talk about that. And that may require the client app to do some additional verification, like I said in yellow there, right? Do some sort of secondary verification. Is this really the TA that I wanted? Check the hash, check the developer signature on it, check the version number and things like that. So And as we kind of use some of these sequences to talk about like the TIDs and the RIDs, if I've got multiple TAs talking to the TAM, I may not have a universal agent, right, talking to the TAM. So how we do that, how we get that, the RIDs and things like that to work become interesting. And then, the next slide, I think, is the summary. So as I thought through this, I tried to reduce down what I think we need to do. I think we still need lots of conversations about how the app is packaged and what Teep messages apply to that and what security implications we tie to those. But other than that, that's sort of that TA delivery within a client app. We have to talk about how that works and make sure we preserve the security. EPID needs to be supported as an optional algorithm. We should look at post-quantum key sizes and increase those, because I think they're kind of the smaller sizes, and at least make those optional to support. I think we already talked about the secure boot stuff. I think one of the things we haven't talked a lot about, Ming, and I think we need to have that conversation, is what is the security domain really doing for me? What do I get from that? I understand sort of the container aspect, but do I get access to shared keys? Do I get access to shared data? What does it mean to package 2 TAs in one security domain? Other than just ease of management, right? Ease of management could be one thing, but what does that mean inside the TEE? And make sure we crisp up that definition, and if we're going to continue to use that. And I think it's fine to then say, in some instances, like in ARM, there can be a security domain of more than one. On SGX, it would likely be just one. And then we'd have to look at, if it's valuable, how do we simulate that? Because I think we could do that if we needed to. And I think we've already started to address some of the platform-specific things that are there. So that was really fast through SGX. If you see me around and you have some questions, please feel free to ask me. I'd be very happy to talk to you about it some more. But maybe there's some questions over what we've talked about. We can go back to some of the other slides if we need to.
Now's the time to speak up. So procedurally, Dave has put the list of the recommendations, and I don't remember if it was Hannes or Ming. So we've already talked about having support of the TA delivery within a client application. So I guess rather than reading each one of them again, since Dave has already gone through them, the question that I put here is, are there any objections to the musts and shoulds that are on this list?
Agree with them, fine. Or if you say, yeah, I can live with that, okay. Is there anything that you could not live with and that's on the slide?
This is Hannes. I will have 2 comments. The first one is about EPID. And in some sense, you raised the question of like, how do we accommodate for different attestation mechanisms? Because it's not just the algorithm, it's more than that.
Right.
And you proposed, you sort of brainstormed about the idea on the ETH token usage, and maybe that's a way forward, depends on how that's moving along. But it is indeed an issue that will have implications on both the protocol document, but also the architecture document in supporting those. And we talked about the key usage. So that's, I would say, a bigger change. The other aspect, you referred to post-quantum, and I always, at least for me, I associate it with post-quantum algorithms more like the stuff that Russ is doing with hash-based signatures, not so much with longer key lenses, like as you had pointed out. I think those are recommendations for today's usage, and maybe we need to really, I think it would be great if we could just have CFRG recommendations in general, because that pops up in different groups. I just had this discussion recently in in the ACE group on what key lengths and what algorithm should be used, and is that is we use NIST P256 R1 now, and do we recommend for something else for the future, and so on and so on. It seems a topic that is across working groups, so I would prefer to just defer this to some other group and just make that recommendations and be done with it.
Yeah, I think that's fine, Hannes. So if I were to interpret what you're saying for the third bullet, I don't think you're objecting. I think it's just a question of how we move forward. So again, the question on the floor is, because of time, please only speak up if you have objections, because we're getting short on time.
Things on this slide that you disagree with.
Things on this slide, Hank.
Yeah, I disagree with Teep should not require secure boot attestation. I would agree that Teep should not require the deprecated secure boot and the now current authenticated boot, because that is what it is now. I would strip the term attestation from secure boot entirely. I would Teep must avoid definition and of operations is okay. And definition operations secure boot again is deprecated, it's authenticated boot.
Okay, so you're really objecting to the fourth one.
I want secure boot as legacy and authenticated boot as current. And I would not tie attestation to secure boot because this makes no sense
That's
at
a
all.
fair point. And again, I'm just trying to get the clarification. In interest of time, what I'd
Yeah.
like to be able to do procedurally is, for the ones that we need objection or clarification, we'll put them back on the list, keep
Thanks.
them as an issue track,
Okay,
right?
I
The
can
other
comment
ones is
issues.
just to get confirmation. Otherwise, I don't want this to go on. Right. Thanks.
Trying to figure out how many GitHub issues we want to file as a result.
Yes.
So far, one, okay, we'll file it.
Yeah.
So this is first one is a question. Second bullet, EPID. I remember I actually used it, but I saw that Intel has a patent on it, so we didn't choose it in the beginning. So we went down the path to just use CA. I know you have group public key to play the similar role,
Yeah,
but
let,
now
let me comment on that.
patent.
I think that there's many ways to allow algorithm agility, including ways that include things like IANA registries and so on. And so there are ways to allow vendor to do vendor-specific things that have been done in other protocols. And Dave was just saying, should there be some way to allow a vendor-specific algorithm here, because there's a use case for that for using EPID, and it would be nice if there was some way for that vendor to use this protocol.
Okay. Yeah, must support that one. But I think in the third bullet, I would say should support quantum. I would like to say it already does, but I say that was to me is should support argument agility. And argument agility, because post-mortem quantum as a Hannes we were same page, right? It's a really argument solve, right? ECC and IC is broken by quantum or potentially, right? So
Okay.
size we already have agility there. I think argument agility as a requirement. Say the protocol must support argument agility. I think we already do that today, but
Okay.
as a
So
default.
I'm not hearing the objection. So what we'll
Yeah.
Yeah. So what we'll do is we'll put the fourth one as an issue.
Yep.
We'll put the other ones as confirmation on the list. And it sounds like, what I would ask for those that have spoken up is to make clarifications, Hannes and Ming, right, to the third one for the post-quantum, to put the recommendation for how we could move forward to them. Hearing none, no objections. Sorry, second and third. Yeah. Okay. Any other, is that? Okay. Thanks, Dave. Okay. Any other? Well, I can ramble, but no, we're down to 1.5. So last order of business, did everybody sign the blue sheets? Okay, so just come on up and look for the GitHub, and then once, I guess, one of us will set it up, we'll start working through the issues there for each draft. Thanks, everyone.
You're not going to sign both?
That was like pretty good. Good job. I was like,
Thank you for doing your job.
yeah. So do you know how to set up a GitHub? You want me to set up GitHub?
I have set up GitHub, but I've never set up an IETF.
Okay.
Or want to, feel free. I should figure it out, but I've almost said it.
Oh, okay.